Hello everyone. So we are going to discuss a very interesting property of a geometric figure called ellipse. So first take an ellipse and let's say the random ellipse is x square upon a square plus y square upon b square equals to 1. The length of the major axis has 2a and length of the minor axis has 2b. So in this case, as you can see from the figure, probably x-axis is the major axis and y-axis is the minor axis. Now, an ellipse has two focus. So F is the first one and F prime is the second one, and they are symmetrically located on the axis of the major axis, equidistant from the center of the ellipse. In this case, the center of the ellipse is simply the origin. So if you calculate OF, it simply is termed as C, which is root over a square minus b square. We are not going to go into the details. But what we are here to see is that if you take a random point P on the circumference of this ellipse and you connect PF and PF prime and you take the distance of this PF prime and PF and add them, the value that you get is very curious here because it always remains constant no matter where you take the point P, which shouldn't be very trivial right from the edge, right? So basically what happens is whenever you can see the shot linked here, which basically shows this in place in animation, how this basically works. But let's try and prove it and let's see what the value gets us. So to start off, the value of OF or the distance of the foci from the center is basically C, which is root over a square minus b square, which also gives us the coordinates of the foci as C comma 0 and C prime comma minus C comma 0. Sorry. Okay. And in that way, PF prime should be this and PF should be this using the distance formula because P has been taken as x comma y, a random point, which of course lies on this ellipse. So the parametrization of an ellipse is simple, just like the circle, but with a little twist that you can take x as a cos theta and y as b sin theta, whereas in a circle you simply take a and b as equal to r, right? And that is also another fact that obviously if the major axis and the minor axis become equal in an ellipse, it becomes a circle of radius r, where r is the common value of the major and the minor axis. Okay. So with the tools in hand that this x is a cos theta, y is b sin theta, and the value of c as root over a square minus b square, we go ahead and try and find out the value of pf prime plus pf. So pf prime is simply this and pf prime is this one. Now you can expand it using a plus b whole square and a minus b whole square, and you get this stuff root over x square plus y square plus c square plus 2xc and x square plus y square plus c square minus 2xc. Put in the values of x and y as a cos theta and b sin theta, and you should get this. Also, c square is a square minus b square. If you remember, c was the square root of a square minus b square is equal to root over a square cos square theta plus a square minus b square cos square theta plus 2ac cos theta. Uh, Here we basically tried and made this b square sin square theta and minus b square sin square theta. And we combine them by taking minus b square common, where we get 1 minus sin square theta inside, which is simply cos square theta. We did it in both of them to get this. And now we can write this first expression and the second expression similarly as a squared. Take the a squared term, then take the 2ac cos theta term and write it as 2 times a times c cos theta. And for the rest of the terms, take cos square theta common and write a square minus b square whole into cos square theta. Do the same for this one. But realize that a square minus b square is simply c square and cos square theta is already there. So these two terms are basically c cos theta whole square, right? And now you can see that this is in the form of a plus b whole square and this is in the form of a minus b whole square. And so the square roots will cut off and we shall get a plus c cos theta plus a minus c cos theta. And you do not need to worry about the modulus sign here because obviously root over x square is mod x, but a plus c cos theta is always positive here. And so is a minus c cos theta because if you remember, c is the length of the foci from the origin and the length of the major axis should always be greater than that length, right? So a minus c cos theta is always positive because cos theta is always less than 1. So the final answer becomes 2a, which is the length of the major axis. Thus, we can say that if you take a point anywhere on the circumference of the ellipse and you find the distance of it from the foci of the ellipse, the sum of the distance always remains constant and is equal to the length of the major axis. Anyway, so I hope the explanation was clear, but please let me know what are your thoughts about this and everything in the comments. So thank you.